In this video, we'll learn how to simplify square roots. Our first example is to simplify the square root of 32. Now 32 isn't a perfect square, but we want to see if we can write this simplified, which means we want to break up the 32 into factors where one factor is the largest perfect square that is a factor of 32 and the other factor is not a perfect square. So we want to find that largest perfect square of 32. And one way to do this is to start with a list of perfect squares. So 2 squared, of course, is 4, and 3 squared is 9, 4 squared is 16, 5 squared is 25, and so on. If we need larger squares, you can always use your calculator to help you generate this list. So, looking at the list, we want the largest factor of 32 that is a perfect square. And we can see that here 16 would be the largest factor of 32 that is a perfect square. The square root of 16 times 2 is 32. So we can rewrite that as the square root of 16 times the square root of 2. And the principal or positive square root of 16 is 4. And then the 2, of course, is not a perfect square and does not have any perfect square factors. So this is the simplified version of the square root of 32. Now, what if we had accidentally thought 4 was the largest perfect square factor of 32? Well, let's see what would have happened. We would have started with the square root of 32 and said, oh, well, this is the square root of 4 times 8, or the square root of 4 times the square root of 8, and we would have said, well, that's 2 times the square root of 8, and perhaps then we'd notice, well, wait a minute, 8 has a perfect square factor of 4. So we just continue with this and say, well, that's 2 times the square root of 4 times 2, which is 2 times the square root of 4 times the square root of 2. And again, the square root of 4 is 2. And we end up with the same result, 4 times the square root of 2. So it doesn't really matter if you don't start with the largest. I mean, if you accidentally don't recognize the largest, as long as once you break it down, you question yourself as to whether or not you still have a radicand, which is what is the number under the radical, that might have a perfect square factor, and then continue checking that. Okay, let's work another example. The square root of 27. We want to simplify the square root of 27. So thinking about our perfect square factors, 2 squared is 4. 4 is not a factor of 27. 3 squared is 9. 9 is a square root of 27, is a factor of 27, sorry. As we go to 4, we get 16, right? 16 is not a factor of 27. So it looks like we want to use 9 times 3, which is the square root of 9 times the square root of 3, or 3 times the square root of 3. Now we have simplified that radical. Let's try another. What if we had the square root of 70? That's a little bit bigger number. And one way to approach this is to say, well, let's factor 70. You maybe have done factor trees before. And of course, it doesn't matter how we get started here. We could say, well, this is, what, 7 times 10. Okay, 7's a prime, so we finished there. 10 is 2 times 5, and we see that we have no perfect squares. We didn't repeat any of these factors, so 70 cannot be simplified, right? So we would just stop there. And if we had calculated the square root of 70 as an answer in a problem, that was how we would leave our answer and input it into the as the answer. However, if we calculate something to be the square root of 27, we need to continue and simplify that radical. Okay, let's look at another one that maybe is larger and a little more challenging. The square root of 450. Well, again, we might try a factor tree to help us with this. So let's look at how that would come out. 450 factors to, well, whatever you see. I see a 0 and on the end, so I know that's 10 times 45. And the 10 will further break down into 2 times 5. And the 45 will further break down into 5 times 9. And then I see that 9 is not a prime number. It has factors of 3 times 3. So now I can see that I do have this square, 5 times 5, and this square, 3 times 3. So I could come back up here and say, okay, well, this is the square root of 5 times 5, or 5 squared, times 3 times 3, or 3 squared, times 2. Or the square root of 5 squared times the square root of 3 squared times the square root of 2. And of course the square root of 5 squared is 5, the square root of 3 squared is 3, and the 2 does not have any perfect square factors, so it remains under the radical. And we get 15 times the square root of 2. That's one way to do it. The other way would be to say, well, what is 5 times 5 times 3 times 3? So we could have also worked this problem by saying the square root of 450 is equal to, well, that's 25 times 9, right? 25 times 9, which is 225. So we could write this as 225 times 2, or the square root of 225 times the square root of 2, which is 15 times the square root of 2. The same result.